Tosin. Please clap if you are clapping. Clap like you want to learn. Also, if you have questions for Tosin, please write them down. At the end of his talk, you just read it and he will answer. And don't forget, our hashtag is there.
Good morning, everyone. My name is Tosin. I am here to talk about a buzzword that aims to unite DevOps and cybersecurity. Um, Both fields have been at loggerheads. Security is trying to keep up with DevOps, and DevOps is trying to move fast. So that gave birth to DevSecOps, which is like DevOps Pro Max, like an evolution of DevOps to bake in security at every stage. So my background, like you mentioned, the many things you mentioned, I actually started with IT infrastructure. Then, the natural evolution for that is, DevOps. Everybody had to learn automation and all. I actually participated in DevOps Accelerate 3, where I learned from some of my mentors here to know more about DevOps. So then, plus my security background, I was able to, get myself into cloud security and DevSecOps. So let me start sharing my slides. All right. Putting the sec in your DevSecOps, security at the speed of DevOps. All right, so the agenda overview, we'll talk about DevSecOps. We'll go over some basics. This talk is meant to be beginner friendly, and also people that have been into DevOps and cybersecurity will be able to pick a thing or two. We'll talk about the traditional security versus DevSecOps. We'll talk about DevSecOps concepts and how to stay compliant. So, how many of us are into cybersecurity here, like as our job, or because I know it's mostly DevOps guys. Anybody? Okay. Now only me Wakako. All right. So DevSecOps stands for, obviously, for us that know DevOps, development operations, then just having security somewhere in the middle. So it's the practice of integrating security testing at every stage of the SDLC, that's the software development lifecycle, and it's an extension of the DevOps practice, like I mentioned earlier. All right, so we know the developers, we know the operations guys. Developers write the code. They also stress the product managers and fight the UI designers. Then operations guys, keep the lights running. They deploy via different tools, infrastructure as code or infrastructure as no code, as pipe ops try to preach. So then security, I know most DevOps guys here, you must have had one or two encounters that didn't really go well with security folks. You want to deploy or developers have something to push and they come up with their reports, their penetration tests and compliance checklists. So DevSecOps tries to break up the silos and put everybody in the same boat. All right, so popularized DLC model. So we know about the waterfall model where things happen, like you have the planning, you define, you design, you build. Then so with that evolution, the need for iteration gave birth to agile, like iteration and collaboration. People should be able to work closely. Then that also gave birth to DevOps, which is not really an SDLC, but a combination of philosophies, practices, and tools. So DevSecOps is hinged on this combination, combining cultural philosophies, practices, and tools. So DevSecOps is about ensuring security while doing DevOps. So the normal DevOps thing you do, continuous integration, continuous delivery, decoupled applications, making use of microservices. I've not really been using this mic. Infrastructure as code. So security, baking security into everything you do in DevOps. All right, so before we proceed, DevOps we know, many of us are familiar with, but let's just talk about the why of cybersecurity. And this is a very reputable body in cybersecurity, that's NIST. So they define cybersecurity, and emphasis is on confidentiality, integrity, and availability. So confidentiality means that your data is only accessible, or just think read access by people that should have access to it. Then integrity means like it can't be changed by people who should not be able to change it. Think of your S3 buckets now. So confidentiality means when you have personally identifiable data in your S3 buckets, just anybody can view them. It's not publicly accessible. Then integrity means they can't change it. And availability means that, we hear all the 99.99s. So availability means that this service is always available and your application is also always available. And this CIA triad aims to ensure this. So, yeah, cybersecurity, information security, often used interchangeably, but cybersecurity is more focused on digital attacks. All right, so let's talk about cybersecurity before the DevOps age. So, people used to have separate concerns. Security was viewed as a roadblock, and they had this go figure it out mentality, and you just send reports, you name, blame, and shame whoever is holding you back. Then the process is just typically vulnerability assessment, penetration tests, compliance checklists, and the tools are usually outside the SDLC. You have long turnaround time. After the application guys are done and they've thrown the artifacts to the operations guys, that's how it used to be. Then those ones will look for how to deploy it. Then security will now ensure that, or they can just draw you back and say, this port should not be open, this particular tool is not compliant. After everybody is done, bringing everybody back. So let me give you this analogy. It's like, I don't know how many of us are into sports, but I'm sure we know Usain Bolt, the fastest man alive. So let's say you have a 100-meter race that you're at the finish line, and at the finish line somebody puts a very big obstruction that you need to scale this thing. I don't know how you do it. Just scale, and that is the compliance checklist. Like we need to comply with. Okay, sorry. We need to comply with these standards. Our compliance says you cannot do this and all. So it gives security this perception that it's a roadblock, but it's actually supposed to be an enabler. It's supposed to help the company to stay in business basically. All right, so this is another form of athletics. We know the hurdle kind of race where the hurdles are actually baked into the race. So at each step, you're scaling the hurdle. At each step you take, you're scaling the hurdle, and you are not overwhelmed by these hurdles because they are basically part of the race. So that is how DevSecOps is supposed to work. Secure by default and integrating this security into the existing people, processes, and tools. All right, so security at the speed of DevOps. Security, when you have DevSecOps, you have a common goal. Everybody knows that we're together. You have your stand-ups. The security guy is there from the beginning. He understands the project and he can, come up with the security requirements. Then security at every stage, and false positives are reduced. Then the fact that you have infrastructure as code means that you can also have compliance as code. So no more heavy Excel sheets and all that. You just have it as part of your pipeline, or maybe with use of a service on your platform. Okay, so a closer look at DevOps. The waterfall model, that one is like a staircase, but the DevOps, the planning, code, everything is a continuum. So this is a typical DevOps pipeline. Most of the tests you run in a typical DevOps pipeline are related to functionality. So the unit tests, the like before you merge to the master branch, depending on your Git workflow, the integration test and all of that. So most of the time, these tests are concerned about the functionality, like does this application work how it's supposed to work? So adding security into it means that at every stage, from the planning stage, you have a threat landscape You define the threat landscape. You examine the change impact. You have things like pre-commit hooks, which are tools that are installed on the developer workstation to carry out checks before a push or a commit is made to the repository, depending on how you configure it. So I don't have a demo, but I have a couple of screenshots to just visualize what I'm talking about, because I don't want to jump from one tool to another, because mentioning quite a number of tools. Tests, yeah, you test for the typical things that you have to test at the end of the like release, like how it used to be. But now the tests are carried out. You write, as the QA guys are writing scripts into to carry out the unit test and the integration test. You also include things that will find out things like SQL injection, things that will carry out DAST, dynamic application security testing. You can, include a Docker container from OWASP, like OWASP Zap, and have it in your pipeline, then send the exports, the artifact to you when you're done. Then, yeah, respond to attacks, log collection, SIM, chaos engineering. So all these things happen in the pipeline, and they're happening at every stage. So security is no more seen as that overwhelming thing that you need to do. It's something that is part of your process and it enables it. So just a couple of benefits of DevSecOps. So you have improved security posture, reduced costs because you are not paying ransomware, you are not paying to get your files back from ransomware actors. Then it enhances the value of DevOps, information, improving security integration and pace. All right, so the examples I talked about. So this screenshot is from like Talisman uh, tool. So Talisman, is a tool that works as a pre-push or a pre-commit hook. So we all know what Talisman means, right? It's like a good luck charm, something that prevents you from being unfortunate, right? So this tool is something that if you set it up on the developer machines, by the time they're trying to commit a push on any of the repositories, the files are scanned. Then certain checks based on regex and high entropy values, like you have a couple of strings that look like what an access key should look like. So it detects that and it flags it, and developer can make that change. So this is dependent on developer. Developer can decide to do a forced push, or they can decide to just remove from their machine. But the aim is to have defense in depth, to have multiple layers. So at different stages, if I don't catch this now, I'll catch it later. And you're not just waiting for when everybody's done. You tell them to wait and let me carry out my checks. All right. So security in the IDE. So popular IDs, VS Code, Eclipse, and even Visual Studio itself. You can have tools like Sneak as plugins, where it works like Grammarly for developers, so they can see their mistakes and quickly correct them. And over time, it also improves their security acumen. I believe we're familiar with Grammarly itself. Like, so when you're writing with it, over time your writing improves. You learn some things, and so that's just how having security in the IDE works. Then static application security testing. I'm sure many of us have heard it in different DevSecOps talks. It's just basically scanning the code. It's a white box security test. You have the code, and you carry out the scans. So sometimes it's not as simple. It can be extracting or decompiling the APK or IPA, depending on what you're working with. But the end goal is you are scanning through code. You are looking for things that are going wrong. So one popular tool, I have the screenshot here, is SonarCube. So you can integrate it with the popular source code repository hosting platforms like GitHub, uh, Bitbucket, and co. Then you can also have developers push directly to the SonarCube server, and you set up the scanners, and you can set up quality gates, things that they can also look out for things like security hotspots. They can click, and you can have a discussion about why this should be a concern and what is a false positive, what is not really a vulnerability in your company, let's say it detects a weak hashing algorithm or something, but because you are just using it to generate like random IDs, you're not really trying to use it for encryption. So it's not really a vulnerability alliance. So with time, you can also fine tune these tools, to your environment. Then we have the DAS, that's Dynamic Application Security Testing. It works by sending out scripts. It's a very old form of testing, but now having it in the new way of doing things means that you can actually have it in your pipeline. So popular tools like ZAP, that's a Z Attack Proxy, OWASP has a couple of containers for these tools, so you can have them in your pipeline on Circle CI, on Jenkins, and send a report when the scan is done testing at every run of that stage. All right, software composition analysis is something also worth mentioning. As we know, most application, like what most developers or what how software development works these days is you are just pulling different packages, pulling different containers from different platforms and trying to speed up your work, looking for the packages and the base images that have everything you need. So software composition analysis is about trying to verify that these open source packages are not vulnerable. So I'm sure we've heard of Log4Shell. Anybody? Then Spring for Shell, those packages that were vulnerable and people had to carry out updates. And a lot of companies have been breached by Equifax is one big example where they had a vulnerable version of Apache Struts running after the vulnerability was discovered and it was the remediation, or what's the word, was released, the fix, the patch. Okay, so software composition analysis, this is a sample from, so if you use Bitbucket, I'm sure you must have seen one new thing there like Sneak. Has anybody seen that? Do you use Bitbucket? Is anybody familiar with Bitbucket? Okay, so have you seen that part in your repository, SNYK? So that easily helps you to, carry out software composition analysis for free. And you can see the insights for your Docker file because, now infrastructure is just, text, like your containers, just strings of text that, are now used to build images and all. So you can detect these things before, unlike when, in the old days of infrastructure, you deploy the servers, and then you now have to go back and start doing correction. But now the fact that these things are defined as containers, IAC, infrastructure as code, Terraform, and all that, you can carry out the scans, and you see the option to upgrade. And the cool thing about this tool, which is free and cool, is it can also let you carry out a fix. Like you can so you can see an option there. You can open a fixed PR. So you just have to set up the required authentication, and and that also aids your relationship as a security person with developers because they know, okay, this guy actually understands and is concerned about improving this process. You can just open a fixed PR, and they see the pull request there, and it's part of the repository, and they know what you're talking about. There's no much back and forth. All right, so asset management, something also we're talking about. So we must have heard the term modern infrastructure are referred to as cattle, not pets, right? So when you have cattle, they're just there giving you milk and meat. You don't really care about them, but pets are like pets. So in the old days of infrastructure, before any project, they will make a request for a server. We'll send. I have a couple of people here that or I think just one person that can remember my infrastructure days. They make a request and you build the server, you come up with different checklists and a lot of back and forth. But now everything is working as code, and you can deploy a lot of servers at the same time. So that means Excel sheets and inventories cannot keep up, like manual static inventories, they can't keep up. So good thing is cloud platforms, your assets are there. You know that if you open your console, you see your AC2 and you see the S3 buckets. But what makes it better, what makes it easier for you to know which tool belongs to what and what kind of monitoring and what kind of automation should be done on different tools is things like tagging and grouping them using resource groups, subscriptions. Like Azure makes that very easy. Before you can create a resource, you have your them based on the importance of the environment. This is a very important aspect of security. So yeah, just some screenshots about tagging, then asset management on Azure. Okay, so you detect vulnerabilities everywhere. You have these tools running, you have SAST, you have DAST and all that. You have all these vulnerabilities flying up and down. How do you manage this thing? How do you track this thing and have a coherent view of what you are doing and how to remediate? So there are a couple of tools, open source tools and paid tools. We have ArcherySec, we have Defect Dojo. This is also you create an engagement, then you can either run the scans from the tool, and for some, if you can, it allows you to import some scans, and you can know all the vulnerabilities that are affecting a particular thing. You can know when you need an exception, like this thing does not comply with the policy, but there's an exception because it's a business need. You can have all of this in the repository. So alerting and monitoring. So you need to also, after the production, like after you deploy to production, you need to get alerted for things that happen in the environment. So depending on the level of importance, you might want to have real-time notifications. And so one thing that makes an incident really an incident is when CIA that I mentioned earlier is breached. That's confidentiality, integrity, and availability. I'm sure many of us have heard scenarios where people say they suffer 12 million hacking incidents, but these things are like because maybe they don't really understand that some things have to. So when you understand that some things have been breached, like say your S3 bucket that contains certain type of data was publicly read or people were able to download it and it's out there. So you want to get alerts. Say somebody's trying to brute force your system. So there are tools that help you with that. Guard Duty, Azure Sentinel. You can see what people are trying to do in your environment. All right, so before I round up, I know I started by talking about some guides, standards, policies, frameworks, NIST, and all. So a lot of companies here, a lot of us work for fintechs, right? And you've heard about PCI DSS compliance, ISO 27001, SOC 2, all that stuff. So compliance as code helps you stay compliance by default. So depending on the cloud platform, some tools are there, some services are there. Like on AWS, you have Security Hub that works with AWS config and tries to ensure tracks the compliance of your resources. But the downside is it could get expensive if your environment is really large. So that's where you might also consider some open source tools like integrating with an open source SIEM or XDR like Wazoo that can give you like a PCI DSS or some other compliance dashboard. So one major consideration is you think about the cost benefits. Like these resources on this account, how important are they? And do I need how many resources and how much will I be charged at the end of the month by these tools? So compliance as code, you have infrastructure as code, you have things like open policy agents that can run static policy checks. If it complies, it deploys. If it doesn't, it fails. Then continuous checks. On AWS is very easy. Security Hub, AWS config, checking changes that are being made and if they are compliant with the standards that you are supposed to comply with. So this is a screenshot from Security Hub. So you have the security standard, PCI DSS. You have all the things you're supposed, and you have the things that are failed. Say CloudTrail logs are not encrypted at rest, and all that stuff in an account that contains resources that are in scope for PCI DSS. So all these tools, we need to like consider them and use these resources to stay compliant. So one thing that puts the whole picture together, because we must have heard the quotes begin with the end in mind, right? The end goal is like having a security program or having something that makes everything make sense. And one very popular framework is NIST cybersecurity framework, where you have identify, protect, detect, respond, and recover. So this framework helps you conceptualize what you're trying to achieve. You're not just deploying random tools like, oh, AWS config is cool, inspector is cool, let me click on it, let me run this. You know that you're trying to achieve these things that help you stay secure. So this Yeah, I think this is the last slide. It's a table that contains tools that are related to different core functions in the NIST cybersecurity framework. So for identify, we have things like Macy. So if you have important data on your S3 bucket, Macy can use machine learning to detect where this data is and help you categorize them. For detection, AWS Inspector, Guard Duty, VPC flow logs, and all of that. Then protect. We know about AWS KMS for the management of your cryptographic keys, Cognito for identity. Then this then Azure as well. You have Intune, Service Map, and a lot of tools. So as you're using these tools, it's important to know what is it's actually achieving. You know the what and not just the why or the how. You know why you are doing it in the first place. You know the why. Like I think the why is actually the most important. So you're trying to make sure that you can identify, you can detect threats, you can protect your infrastructure, you can respond to threats. An incident response can be very broad. It can include, sending mails to your customers, depending on the importance of the threats. Then recover things like AWS backup, auto scaling groups, like when, say, they're able to take down one of your infrastructure, like one of your servers, then auto scaling groups, it will spin back another instance, cloud formation and all. So this just helps us conceptualize everything. So in summary, I tried to run through a lot of things, but in summary, DevOps starts with a cultural change, and everyone is responsible for security. So it's not just about the tools. I try not to really focus on any cloud platform or any type of tool, open source or paid. It's not really about the tools, but ultimately you need tools to get the job done. And lastly, security cannot afford to lag behind. Security needs to, move at the pace of the company, and everyone needs to help security move at the pace of the company. That's developers, DevOps engineers, project managers, everyone. So that's it. Thank you.
Thank you very much. We have questions. Any
Questions?
questions for Tosin? One, two. I can only take five questions. You've written it down. I use yes.
Yeah.
So I just want to understand. When you said that Snake detects vulnerability when we integrate it as a package in our
ID, yeah.
in our ID. So I don't know. I want to understand how it does that. Let's assume
Okay.
I'm working on a C sharp code. Okay? So I want to understand: is it in our solution? Well, after we've done coding and everything, or during the coding that it does check for vulnerability?
Okay. The way Sneak works, it can be as part of your repository. That's Bitbucket. It's integrated by default. Then, if you have the ID, you have to click on run scan. Then it's basically does SAST, that's static application security testing. It might not really have might not understand the context, but there are some things that just look like XSS, like the way you are taking the input from the form, and there's no sanitization in place and all that. So it can look at, or it can look at software composition analysis. Let's say you're working on a Docker file, and your base image is a vulnerable version of Node or something. So it's integrated with many platforms depending on the kind of check it needs to do. So if you use SonarCube as well, that's SonarCube is like a SaaS tool as well. So that's how it works. It tries to work with, let's carry out checks based on known patterns of vulnerabilities. Yeah. Yeah. Thank you.
My question is,
You what? Okay.
when they do the open sheet application that manage Kubernetes,
Okay.
they
Okay.
are telling the whole world that the Postman has a rootless, it has a rootless
Less container. Yeah.
So why Docker has those? So can we now say that from the security perspective, it's
Yeah.
not really addressing the continuity?
Okay. Thank you for that. So Docker, you can have rootless containers on Docker. So if you Google it, you see the steps. You basically have to, instead of allowing it to run as root, you have to import a few packages, I think one or two, that will let you change the user ID and specify the user ID that the Docker is running as somewhere in your Docker file. So it's very possible. There are rootless containers on Docker. If you check out Docker, you see it. So Podman, because I've never actually used it, but yeah, because um, it's secure by default. It uses the rootless thing by default. But because many people don't use Podman, people always still prefer Docker. So that's why people are still leaning into Docker. And the fact that you can make those same changes in the way, like you can specify a particular user ID, you can give it a range of IDs that don't belong to root for it to run as. So those root privileges are no more in the container when you make your Docker a rootless container. So in summary, you can make Docker work as a rootless container, and that makes it, you know, beat that whole vulnerability or that issue of running as root. Thank you.
Especially for the non-sector.
Yeah.
Especially after like end of grade and having regular. My
Yeah.
question is about the CID fire.
Yeah.
Still along the lines of your implementation. What is CID fire?
Yeah, CIA triad. So when people hear CIA in terms of security, they're thinking of the Central Intelligence Agency, but it's actually an information security model for you to conceptualize components of how to secure things. So you know confidentiality means that this thing should only be accessible to people that are authorized to access it. So let's say you are creating an application, then you are storing people's confidential data on your S3 bucket. You know that confidentiality is a requirement. And when the security guy is working with developers, he's thinking, like, the guy is showing him IAM policies and all that stuff, but he's thinking, like, I hope confidentiality is ensured. So it's a model to just think through things. And integrity, like when you're talking about the put request and people that can, when the DevOps and developers are thinking in terms of policies and how to do things, you are thinking as a security person, you are thinking that hope integrity is ensured. Then when you are looking through policies or the principals that have access to different things or the application or anything, that CIA triad, it just helps you to understand how to ensure information security and cyber security. So we know infrastructure as code, right? We know that you don't always have to use the console. Then you can also still integrate and use something like infrastructure as no code. But one important aspect is when you are doing so if you are doing things from the console, you can have a lot of guardrails in place, like control tower on AWS and security policies and all that stuff. But when you are doing things as code, you need to be able to verify those things as code. So there's something called Open Policy Agent, and they have a couple of tools that have been built on it. I think regular, Frigate, and you can have those things in your pipeline. Just how you run unit tests for, let's say, a functionality in your code, and integration tests. You will run those tests. So let's say you have a requirement that all EBS volumes must be encrypted, or no wildcard in your policies, or S3 bucket should not be publicly accessible. There should be no policy that's granting public. Yeah. So you can define those policies and make sure that your infrastructure as code runs against those policies in your pipeline. And when it doesn't comply, when you detect, so I don't have any of such screenshots here, but if you can just have it in mind, open policy agents, regular, Frigate, you can actually detect these things and you see all those violations. And then you can now see that, okay, this infrastructure as code is not coding with our platform. Yeah. 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 What happened to the mic? Okay. Yes, sir.
So I want to ask that as a startup, what steps can you take to prevent breaches of your data in your S3 bucket?
Okay. So as a startup, you actually have the advantage that you don't have many resources flying around. So it's easy. when you work with, say, a security consultant, or you're patient enough to have somebody in the DevOps team or the security team, review all your infrastructure and make sure that. So a good way to start could be the NIST cybersecurity framework. You can use that to have a guide, like as a guide to say every aspect of your infrastructure, your S3 buckets, your VPCs, and all. You are able to identify where everything is. You identify the key resources that are related to each of these things. You are able to detect. You have monitoring tools in place. As you are monitoring the functionality, the uptime, availability, all that DevOps stuff, you are also monitoring the security. How many brute force attempts on this EC2 instance? Let's say for an EC2 instance that's publicly accessible for some reason, then you monitor all these things and ensure. Then you also have to know that sometimes with all these mechanisms, if it happen, right, anything can happen. So you have things in place to respond to threats. Let's say somebody can gain access to a very low privileged user, but with the alerts, you can quickly prevent them before they escalate privileges. And finally, make sure that you can recover, because you know aside the whole hacking thing, availability is also part of cybersecurity. So losing even if AWS or one region goes down, it's not an excuse to your customers. If they cannot access your application, they can't access it too. Having it in mind that you also need to have things in place to recover if you are either hacked or the platform that is giving you, that is hosting these resources, go down. So using something like NIST, CIS benchmarks and all would help you have a good understanding of how to ensure security in your environment. And it's usually cheap with cloud native services when you are a startup, when you don't have many things. I mean, if you enable Guardity, all those things, those inspector, you are charged based on number of resources. So as a startup, if you have just a few instances, it's even better for you to enable them. And but you don't just enable things for enabling sake. You also have to work with a framework, CIS benchmarks, NIST cybersecurity framework, and all to have like a structure and a security program in place to make sense of all your security efforts. All right, that was a long answer.
Okay, let's start for Tosin.
All right.